Hi everyone, welcome to Vishesh Educational Videos. In this video, I am explaining about estimation techniques. Estimation technique means how much effort is needed to develop that software, how much cost is needed to develop that particular software. We need to do estimation, how much cost is needed, how much cash or what is going to be the cost, right? How much effort we need to develop that particular software, to calculate the cost, to calculate the effort that is needed to develop that software. We have some estimation techniques. Particularly we have the Cocomo 2 model. It's going to tell how to calculate the effort, how to calculate the cost that is needed to develop a particular software. I'm going to discuss this Cocomo 2 model in this video. If you are not subscribed to my channel, please subscribe to my channel. To get the notification of my videos, please click the bell icon, and please don't forget to like the video, and please don't forget to share the video with your friends. So organization need to make software effort and cost estimates. They need to calculate the effort that is needed to develop the software. The companies need to calculate the cost that is needed to develop the software. There are two types of techniques that can be used to do this. So first is experience based technique. So here the estimate future effort requirement is based on the manager's experience of past projects. Obviously, if a manager is having the experience of doing the same project earlier, his experience plays a very important role to decide the how much human power needed to complete the project, or how much money that is needed to complete the project. So here manager's experience plays a very important role, right? So essentially the managers makes a decision, right, about how much cost or how much effort is needed to complete that particular software. Next is the algorithm cost modeling. This is the second approach. In this approach, a formulaic approach is used to compute the project effort based on the estimate of product attributes. Here formulas will be there for each and everything. Formulas will be there. Based on the formulas output, we can decide the how much cost or how much effort needed to complete the particular software, right? So experience based techniques rely on judgments based on the experience of past projects and the efforts expended in these projects. In simple words, experience based techniques based on the judgments of the project manager, because he is having the experience of developing this same type of softwares earlier. So based on that experience, in this time also he can use that experience while developing the particular software, right? So obviously when you develop a particular software, you document these things in a spreadsheet applications, right? So and you can use that spreadsheet application to estimate the particular cost or particular effort next time also. Same thing you can use next time also. And also it usually helps to get a group of people involved in the effort estimation and to ask each member of the group to explain their estimate. This is a good idea. We can ask each and every people that is related to the project, right, to calculate the effort estimation, right? Each member will come up with their ideas, right? Based on that we can take a decision, right? So algorithm cost modeling, as you know, it's a formula related method. So here for example, in this algorithm cost modeling, cost is estimated as a mathematical function of product, project and process attributes, whose values are estimated by project managers. Project managers are going to estimate these values, right? So here how they are going to estimate those values means using the mathematical function or a mathematical formula. Using that they will estimate that. So this mathematical function contains the combination of the project attributes, product attributes and the process attributes. All three attributes you need to take care. So here this is the formula to find out the effort. So effort will be find out using effort is equal to A into size of B into M. Here A is an organization dependent constant, B reflects the right, disproportionate effort for large projects, and M is a multiplier reflecting the product, process, and people attributes, right? Simple formula this is. The most commonly used product attribute for cost estimation is quote size. Cost estimation. So to do the product attribute, if a quote size is more, the cost will be more. That's why the most commonly used product attribute for cost estimation is quote size. And most models are similar, but they use different values for A, B, M. So organization dependent cost constant is purely based on the organization capability, right? And a large project, obviously B also reflects the number of human power that is in the company. So different companies will get different values for this. And estimation accuracy. The size of the software system can only be known accurately when it is finished. Obviously, to know the to know the size of the software system, right? How it will be accurately known when it is finished. So several factors influence the final size of your software, right? So for example, programming language, what programming language you used, that will definitely influence the accuracy of the software. Some size may be increased if you use one programming language, or size may be reduced if you use another programming language. And also use of COTS and components, they are based on what type of components you use, that also affects the final size of the project. And also distribution of system, also the distribution, what type of distribution you have adopted, though the distribution of system is also going to affect the final size of your software, right? As the development process progresses, then the size estimates becomes more accurate. Obviously, as the development process goes on, obviously the size, you may get the accurate estimation about the size of your project, right? Hope you are getting. I suppose if you have any doubts, please post your doubts in the comment section, right? And the estimates of the factors contributing to B and M are subjective and vary according to the judgment of the estimator. B and M means, I told you, the effort of large projects. M is a process, people attributes. These attributes are going to change with respect to the companies. See, right? Next, the Cocomo 2 model. So what is this? This is model based on the project experience. The Cocomo 2 model is based on the project experience. It is a well documented independent model which is not tied to specific software vendor. This model can be used for any software calculations, right? And Cocomo 2 takes into account different approaches to software development, reuse, etc. Cocomo 2, it takes all the different approaches. It takes all the approaches into account and it will calculate. So now I will explain this Cocomo 2 model now. If I say a Cocomo 2 incorporates a range of submodels. Cocomo 2 model can be divided into range of submodels that produce increasingly detailed software estimates. For example, see, these are all the different submodels of Cocomo estimation models. I will explain that. See, the submodels in Cocomo 2 are application composition model, next early design model, next reuse model, next post architecture model. These are all the submodels of Cocomo 2 models. So this will give the detailed estimation about different things. So see, application composition model is used when software is composed from existing parts. You are not using the entire new parts. You are already using the existing parts, means you go for the application composition model. Early design model used when requirements are available but design has not yet started. If you want to find out the estimation of cost, you can, but you have the requirements, but you don't have any design thing, but you need to estimate the cost, then you can go for early design model. You can go for reuse model when reuse model is used to compute the effort of integrating reusable components. When you used reusable components to your software, if you want to find out the cost estimation, you can go for reuse model when you used integrating reusable components. Next, post architecture model used once the system architecture has been designed and more information about the system is available. Whenever the architecture of your software is completely ready, then you can go for a post architecture model to do this effort and cost estimations. See, application composition model is based on the number of application points and used for system developed using dynamic languages like DB programming, etc. I told you composition model is used when application is developed or software is developed from existing paths. See, early design model, when you only have requirements, you can go for early design model. When you use only reusable components, you can go for, see, based on the number of lines of code reused, based on that you can go for reuse model. Based on that you can calculate the effort, right? Here also you can calculate the effort based on the requirements, number of function points. Here number of lines of source code. Based on the number of lines of source code, you can use it for the calculation of the effort based on the system design. This one, development based post architecture model is going to be used to find out the effort based on the system design. Here effort to integrate reusable component. Here initial effort. Here if a system is developed using dynamic languages, you can go for application composition model. Right? I don't want to confuse you guys. Application composition model supports prototyping projects and projects where there is extensive reuse. I told you, when you are reusing the already developed components, that means when you use the components that are already used in your existing project, you should go for application composition model. Right? So based on standard estimates of developer productivity in application, so you have to calculate application points based on months or weeks here. Right? So to calculate the cost estimation, the formula is, see, this is the formula. Here PM is the effort in person months, NAP is the number of application points, and prod is the productivity. Application points means, I told you, for example, 1 month you have to divide your project like months. To complete your project, 12 months means you should have 12 application points. That is the application points, right? PM means is the efforts in person month. For how much person months? For example, 30 people needed for 1 month, like that, person month. So based on that you can calculate, right? See, developer experience and capability, if it is low, see, this is the table. So this table, I'm not going to stress more on this table. It will be confusing for you guys, right? See, very simple. No need. It may confuse. See, I will move on to the early design model. Estimates can be made after the requirements have been agreed. Here requirements are there for you. Once the requirements are there, you can go for the early design model. So here the formula is equal to PM is equal to A size B M, where M is equal to PRS. See, these are the matrices. I will explain what are these things. These are all the different matrices, right? So what are these? RCPX means product reliability and complexity. RUSC means the reuse required. PDFC, I'm using all this. M contains these matrices. A means what? A is the value, constant value 2.94. B value is what? It is from 1.1 to 1.24. But M contains these matrices, different matrices. Based on that, here this is simple. Based on the formula, you are going to calculate all these estimates. See, PDAF means platform difficulty. PRX means personal experience, that means staff. PRS means staff capability. SCED means required schedule. FCL means the team support facilities. All these things is going to affect the calculation of your cost and the effort. These are all simple formulas. So in the application point productivity also you have used a formula. Here also in this early design model also you are using a formula, right? I'm not going to concentrate more on this table, right? No, it's not that important. Next, the reuse model. See, the reuse model takes into account the black box code that is reused without change the change and code that has to be adapted to integrate with new code. That means here the reuse model takes the part of the program that is going to be reused in your new software without any changes. Black box reuse means here the code is not modified, just you will take the code and just you can use it. White box reuse means the code is modified, right? Hope you are getting effort estimate is not going to be affected in black box because you are not going to do any changes, but if it's a white box reuse you are going to do the changes. Obviously the estimate is equal to the number of lines of new source code is computed. Obviously how much new lines of code you have written along with the reusing of old code also. Hope you are getting, guys. These are all related to formulas. If I say a reuse model estimates 1 and reuse model estimates 2, both two models are there here. For generated code, PM is equal to ASLOC into AT divided by 100, AT divided by AT PROD. Here ASLOC is the number of lines generated code, number of lines of generated code. AT is percentage of code automatically generated. AT PROD is the productivity of engineer in integrating this code. Based on all these factors you can calculate the effort needed. In the second thing, when code has to be understood and integrated, here you are not doing any changes. Here if you are making changes you can go for the model estimate 2. Here formula is ESLOC is equal to ASLOC into 1 by 80 divided by 100 into AAM. It is like ASLOC and AT are as before. You already seen what is ASLOC and AT. The AAM is what? AAM is the adoption and adjustment multiplier computed from costs of changing the reused code. So these multipliers are going to be calculated using the costs of the changing reused code. Based on that they are going to calculate. Here remember one thing, guys, here just try to remember the formulas. Here directly you are going to use the formulas. Based on the formulas you are going to use the values and you are going to get the estimations. Formulas are very important here, right? So these are the different Cocomo models, that is reuse model, early design model and the application composition model. These are the 3 sub models of Cocomo model. All are purely based on formulas. If you know the formulas you can calculate the effort and the cost estimations. Now this is a separate part, that is project duration and staffing. So based on how much duration you need to complete the project, based on the project how much staff you need, those things. See, managers must estimate the calendar time required to complete a project and when staff will be required. Calendar time can be estimated using a Cocomo 2 formula. See, to estimate how much time you need to complete a particular project, you can use the formula, this formula. TDV is equal to 3 into PM of 0.33 plus 0.2 into P minus 1.01. You can ask how you get the formula. Means these formulas are already calculated, right, in the early 1980s. We are just using these formulas to calculate the estimated calendar time, right? PM, what is the PM in this formula means? PM is the effort computation of, and B is the exponent component as discussed above. B we already discussed there while using a Cocomo, right? Next, staffing requirements means staff required can't be computed by dividing the development time by the required schedule. The number of people working on a project varies depending on the phase of the project. Obviously, if the pace of the project is good, people needed will be less. If the pace is very much higher, if very less, obviously you need more number of people in the project. You can't calculate the staff required by diving the development time. No. It depends on the phase of your project. The more people who work on the project, the more total effort is usually required, obviously. Right? The more people who work on the project, the more total effort is usually required. Right, guys? So hope you understood the concepts. I know it's a very tricky one, because most of the things are purely depend on the formulas. If you know the formulas, you can apply the formulas, you can calculate the values, right? So still, if you have any doubts, please post your doubt in the comment section. I am happy to help. Thank you for watching the video.